notes are all of you. So I don't want to take notes. Speaking of, that's why my lunchbox was there. Oh yeah, I have papers to pass back. That's one of the things I'm worst at, guys. So if I need to pass back papers and you've been like waiting for stuff or whatever, your grade's normally changed in math. But if I need to pass back papers, just like, let me know or ask me. Often the answer would be yes. We're going to get through more than a page of notes today. So just throwing that out there. When we transform shapes and perform a rigid transformation, what can we say about rigid transformations? What's that, Logan? The size does not change. So, apparently the wind is going to choose who gets to go next. The wind just blew Maya off the stack and decided Rachel was next. All right, so when relating an image to its pre-image, it is important to remember that rigid transformations preserve the size of the shape, including all lengths and angle measurements. Only location changes. Kelly. Yeah, rotations are. You sure? I mean, I'll dig into this if that's what you tell me, but right now I don't have a good answer for you. Nick said he got away with it. So I'll go check it here probably like during class, but we got to get through this right now. I can't diagnose con at the moment. So, guys, these notes are going to be really fast. The only reason there isn't more here is I wanted you to have some space to show your work. The translation that happened doesn't really matter that much. What matters is that it has only been translated, right? So they tell us 9 units to the left, 3 units up, so boom, here we are. What is the length of segment A prime, B prime? Well, if we know that everything on a rigid transformation gets preserved, what's the new AB? 8, right? Let's label all, that feels too easy. Let's label all of the parts, right? So if I didn't know it on the original, let's label it. If I don't have it labeled on the prime shape, let's label it. Ooh. Do we know angle C? Who said yeah? Yeah. We do know it. If you don't know how we do know it, take a moment. We do know it. See workspace. That's also why I left. 59? I'm glad you're here to make sure my math is right. Yes. So, second one here, same story. Right? What is the measure of B? Aha! Here's where we have to use that triangle sum. So, if in the first one it wasn't evident of how we were doing this witchcraft, if we know 2 of the angles, we actually, in quotations, right, we actually know the third. Well, we don't know it yet, but we can figure it out. Because what we do know is all 3 angles sum to 180. So if you need to remind yourself that A plus B plus C is going to be 180, do so, and then do the math for if A is 80, C is 26, B is going to then be 74. Now, a tad bit trickier, but still really not all that tricky. In a reflection, notice how it's not so straight up as left side, because when we reflect, we mirror everything. So the measure of angle C here, okay, well, the measure of the angles, that's kind of easy. Let's also label the lengths. So label everything in both of these. Take a moment. Label everything in both of these for the reflection. He's just making sure his answers are right. Like, I don't pay for wrong answers. You know, all those big bucks. You know you're getting paid double now that you came back full time, right? We're going to double your pay. It's that terrible math teacher joke about 2 times 0 is still 0. Ha-cha-cha. I don't know. Genuinely do not know. What? 54? Colin says, hey, we can chat as long as we can all come back. I can make terrible jokes. Well, I'm always going to make terrible jokes, but you guys just have to be able to come back from it. Colin says 54. Can I get some verification? Yeah. All right. What would CB measure? 57. AB? Guys, what's AB? We don't have AB. So until you learn trigonometry, you can't figure this out. Oh, yeah, you do. Trigonometry is awesome. All right, take a moment. Come down here, read. It's going to take you a moment to read where you're not talking. Read all of these and decide what is true. What is true? Don't worry, the back gets slightly more difficult. Then go ahead and flip to the back, so I'm going to pass a bunch of stuff out. Then go ahead and flip to the back and read through / work on those problems. Progressing on this, I was pretty strict on well, you made a mistake, here's progressing. So just fix it. Well, hey, that's what mastery is. You work on math? It's not in math yet. I have it written down. So again, my traditional how I like to grade. I got your grades right now. Your parents don't, right? You got your grades once I hand it back to you. You're in control of changing it before it hits math. So for masteries, right, I'm kind of bad at this, I get to do it too. But masteries, make your revision today, tomorrow. I probably won't put it in math until later tomorrow. Right? So you get it back to me, AO or extensions today would be awesome. Just get it back to me, and then your grade won't be lost. Your revisions are good. On the back, you gotta turn your brain on. For the part about would one or both of these work or either or that's an example. So at the top, I guess we should talk about at the top. I'm still coming around, but people started asking about the back. At the top here, this is an example. Triangle MNO maps onto triangle ABC. I know we are used to prime notation. We don't always use prime notation. Sometimes the image is a completely different labeled point. So MNO maps to ABC. Both of these shapes exist, so they like to have their own names, as opposed to one being the prime of the other. If you're a little or older brother, trust me, you don't want to be Brad Prime, right? No, I'm not. I am not Brad Prime. Thank you very much. I am me. So sometimes we have our own names. So this is an example of we go ahead and do the translation. Okay, this is on. we go ahead and do the translation, and then I show you the reflection line. Yeah, that was bad. The reflection line, and we flip over. So now, you gotta read these and try these. So would either / both of these work? Either is not that. Yeah, that's why up here with either / both, like, or like, if none of them work, then yeah, your answer is just no to each of them. So this you can move. They had it there last time. If you want to come up any further or whatever, you're able to move that in my room. That's like the extra. That's just the one I get rid of the whole. Which that I don't like when people go, oh, I thought I didn't know this. That doesn't make me feel good.
Well, I thought it was just a mistake.
I think this is you. Tell me if it's not, but I think it is. That looks now right, he says. That's not a yes or a no. That looks.
That's a maybe. Wait, do you know your own handwriting? I just know it's
You don't know your own handwriting?
No, I know mine is terrible, but like I'm so inconsistent that like one page is not one.
A, B. My handwriting's not.
I owe you and sometimes Y.
That's
You
no.
owe me. What did you? Oh, I'm sorry, dudes. I'm real bad at this game. I actually did no brackets. I'm too busy with schoolwork. Sorry, that's my honest answer. I mean, Ohio State already lost, so whatever. Like, I mean, that just shows upsets, right? Like, the nature of a tournament. Yeah, do you know how? Well, that's the less COVID-friendly way. There's also the one button. All right, here we go. Down here, Maya, would a translation along the directed line segment. Wait, directed line segment. Ooh, we got to go back up here if we don't know what a directed line segment is. A directed line segment is a cheater's line. By directed line segment, they're like taking the shortcut of instead of defining what the line is and instead of defining what the translation is, right? So instead of saying translate left and up, we can kind of cheat and call it a directed line. So a directed line connects one point to another. So if you want to go ahead and draw your own directed line over here, the directed line NB is that. It just literally says, hey, you drag over here. Thanks. Great. Because, guys, honestly, a lot of times on the computer, you can just grab it and drag it. Like, you can point a vector, right, like an arrow, and say, go here. You don't actually have to say -7 + 2, like, or whatever it is, right? Go left and go up. You don't actually have to say that a lot. So, Maya, a translation along the directed line segment DB. All right, so we're going to get this over to there. Then a 90-degree rotation about point B. What do you think? Why? Ah. Yeah, if we just drag this up, and then 90, it's like, it's up here, right? Because it would be pointing, hockey stick. Hockey stick, remember that? Here, making a hockey stick for you. You guys are playing floor hockey now too, so it's perfect. Alright, so if you imagine a hockey stick as like your triangle, right? Because we talked about hockey stick translation method. The point of my triangle is the blade of my hockey stick, quote unquote, whatever. So we slide it up. My point would be pointing right. And then they say, rotate 90 degrees. Now, wait, I heard the question of like, which way? What way is a positive rotation? Counterclockwise. So my point of my triangle is pointing up. My point needs to be pointing down. Sequence A, not going to work. Rachel, what about sequence B? It also would not. Crap. I mean, neither of these work? Oh, dang. So neither of these work, guys? But here's the problem. There's not really a depending on which a positive rotation counterclockwise. So, a positive rotation about F, right? But then F is still where it is. Then a translation on the direct line F to C. Our points would be like pointing at each other. A positive rotation is counterclockwise. I know it's silly, but that's what math said. They're like, hey guys, positive rotations, you want to do what everyone else does? They're like, nah, let's do it the other way. Now, remember, this is because this is how the quadrants are numbered. So, counterclockwise for positive rotations. So this, hold up. This will point your triangle down like this. Right, then if you slide it up, we're still pointed down like this. That's why it does not work. Okay, so neither of these, okay, let's move on. That was disappointing. Disappointing. Logan, what are you thinking about sequence A here? You guys want a moment? I mean, I need to pass out notes anyways. This magic moment. Is that the length of one? Oh, I thought they were here because I was going to hold something. No, you're not. We were going to do more than one page today. This does not mean we're doing more than one day worth of stuff, so please don't all be like, not only was Hudson like what he normally does, he went double time. Like, guys, we're just ready. Like, and I want to make sure we fit in as much as we can. So, please remember the Khan Academy due dates are just as of right now. That's my goal. If you tell me that's like unachievable, I can always extend it. Right? I'm never going to make them sooner, but I can't extend them. Logan, your time's up. Gentlemen, knock it off. That's the last thing I do in my classroom is time. I don't even actually know if that was the right time. Yeah, you just felt like you needed to jump in on the joke that wasn't funny. Yeah. That's when saying nothing's the better option. Sorry, guys. We know you well at this point because we've been together all school year. We're really honest with you. And I hope you like that because that's just how we are. Translation 2 units to the right, 10 units up. Okay, well if I map it out, I like that as I walked around, some of you were drawing the mapping of the translation. Then a reflection line, AC. So Audrey, I really liked the drawing on your paper that I saw. Do you think sequence A works? No? Yeah, sequence A doesn't work, does it? So normally they're giving you the pre-image mapping to the image. Normally, like with the order of. And if I take ABC to the right and up, it's obviously not going to work. Like, that's just right out. So the only sensible thing that could be moving right and up is to grab XYZ, move it right up. Yeah, this is not in color. Blue-gray. You move the blue one. All right. What about B? Oh, my camera disappeared. For B, Sophia, what do you think?
It doesn't work because even when you go six to right and six up, it doesn't meet up to there.
So it gets Y to B. Oh, wait, it does. This does work. So if we draw it, when we get Y over to B, this one would look like this. And I forget how long the bottom is. But then if we rotate, 180 degrees doesn't actually matter which direction, but it's positive, so we should think about it this way. Guys, this is one way that you know 180 will line up. Notice how what I have right here actually continues like right up into the new one. With this being the center of rotation, that is what happens with 180 degrees, right? It points the opposite direction. Question or just stretching? Okay. All right. Any questions about our properties notes? Because then we're going to move on to the eye doctor and go dilate. So if you go to the eye doctor, which hopefully you do, they dilate your eyes to check your, I don't even know, I think they just do it to be jerks.
No, it's because then they can look inside the hole. No, if you put lines around it, it's smaller.
I think just a while ago, they were like, you know what would be funny?
Dilate your eyes, check if your eyes work. No, dilate your eyes. That's not how dilation make it so.
Guys, how do I put the pin back in the grenade? Because I feel like I said one thing, and it was like I threw a conversation grenade. It was like, everyone's talking. So let's put the pin back in the grenade, right? Don't tickle the person with the grenade. That's always a good rule.
Well, I think generally not
A dilation, you are correct, Nick, changes the actual size of the object. So one thing we can say it does is it changes the distance between 2 points. Even if you're changing the size of the shape, it's changing the distance between 2 points, right? Because the edge length is the distance between 2 points. So the first thing we're going to dilate is just the distance between 2 points. But before we do that, answer this question on your paper. Not out loud yet. What does a scale factor of 1 do? What does this? If I scale something by 1. Guys, your pencil not being in your hand is a real evident indicator that you're not doing what I'm asking. Gentlemen at the back, I'm required to, you guys should scooch apart a little bit. We're still trying to keep 3 feet distance. Yeah, thank you. I know it feels silly, but that's what they've done the research with, so that's why we are asked to try to preserve that. Because if one of you gets, so have people explained this to you, like, well, so now the rules of who tests positive and who is technically exposed has changed, right? So if we can say with certainty that, like, you were not close contact with somebody for more than 15 minutes, which close contact is now within 3 feet, which, dude, the research, this is the research.
I know.
You can have opinions, that's fine, but I'm not arguing research right now, because it's research. So, like, please know when us teachers are like, hey, spread apart, we don't want to do that. We wish we could say, hey, get together and work on this. Hey, get together and talk about this. We always, pre-COVID, are saying get together. So, please know when we say, like, hey, get on the ends of the table or stuff at lunch, especially lunch, guys. Like, Mr. Flynn, like, kind of came down on the teachers and was like, yeah, you guys gotta, like, be walking around checking 6 feet and, like, telling people to spread apart. And, like, telling Dewan to get his mask back on right now. Except you are actually probably 6 feet away from people currently. Yeah, we can't eat, really, during class. We can take our mask off, take a quick drink, but that's it. Like, I know, you're okay, but, like, we really can't, like, you know what I mean? Like, we can't really do that stuff right now. Can't hang out with mask off. I wish I could, trust me. That's why, like, my mom made mine extra big, because I'm like, I can't talk when my mask is super close to my mouth. So that this covers me, but I can still talk. What's a scale factor of 1 do? Anybody, everybody? Nothing, right? Nothing. Now, what about a scale factor greater than 1? What does that do? That gets bigger, or that would be an enlargement. And a scale factor less than 1 is a reduction. Both of which are called dilations. So whether we're getting bigger or smaller, these are both dilations. So when we're asked to plot the image, remember there's only pre-image and image. Plot the image of point C, so we're moving point C. Right? The image of point C says we're going to move point C under a dilation about point. I hate this word. It means you're working with that as your, like, starting location that you reference from. So if you say, like, my grocery store is half the distance between here and my home, it's like about my home. Like, I'm referencing my home. So, like, P is our reference point that we're going to move C either closer to or further away from. So if I said, my wife and I are moving to a house twice as far away from school, right? But I don't know why we use the word about, but in mathematics we do. I disagree with it because words like that confuse me. Because it's like, why are you using the word about? But with rotations, it feels appropriate with rotations. Rotate about the point, like around the point. Adam? Yeah. That would be plural. Plural. They could have done a lot of things, and yet, here we are. They could have done a lot of things. Yeah, and, you know, the wizards on Harry Potter could, like, fix all the world's problems, and yet, they don't. So, here we are. So, I should have known better than to bring up Harry Potter, but back to our translations. If we say the snitch gets twice as far away from Harry as it was, I don't know. Voldemort, ooh, Voldemort. All right. You guys ready to try it on your own?
Potentially.
I'm pretty distracted by the nice weather and everything else. Just go ahead to the bottom and try this on your own. If you get done with that, flip to the back. Sometimes we dilate from the origin, or they say about the origin. Sometimes we dilate from a point, or about a point. Only if you make it, so let's not. I'm just going to stop you right there. Reminder, I'm recording every day now because this is always new. Any sentence from a 12 or 13-year-old that says that sounds suggestive and then continues on is going to be dangerous. So we're going to call our dilation to point D one of the more simpler dilations because we're really only working in one direction, right? Not the great boys band. But, no, in sync all the way. So if we are going to dilate with a scale factor of 3, means everything, which here we only have one thing, the distance on the x-axis, everything will get tripled. So our distance of 2 that we see right now is going to get tripled to a distance of, and we land at -6. But then, when we go to dilate point A from P, what are you asking to do it then? Because it doesn't really have a coordinate. Or you can tell me what to do.
So, why do the first of P is 1 up and 2 to the side? 1 up and 2 to the side of A. So, I went down 1 and went over left. And that was kind of 1. It's still right there 2. And then you do it again. And that's still right there.
So Dewan's saying every time I do this, so this is your scale factor of 1, right, to start. So coming down here is a scale factor of, so I'm trying to write an S, is a scale factor of 2. This gives me a scale factor of 3. Every time we do what the distance is, it is a scale factor. I like how you described that, Dewan. So we go scale factor 1, scale factor 2, scale factor 3, and we stop. P prime. It gets named Junior. I always feel like Junior is such a terrible name. Due to restrictions on the computer, your directions for A, then A is down here. Your directions for B, and then B is over here. Right? I just needed to fit stuff in. So your directions for A and B. Try these on your own. Cheryl, I can wipe your desk if you just need to get out of here. You're good. I'll get it. Now with our fractional scale factors, remember we are going to be reducing distance or size. We're going to be reducing our distance or size. Huh? Sweet. Have a good day, Charlotte. Yeah, don't forget your phones here, guys, because I'm not driving. Well, I'll be here till 6 o'clock tonight, actually. So if somebody forgets their phone, I will be here. Contact me if you need to. I'm doing conferences with the newbies that are coming in. Our new Phoenix peeps. Did you hear Adam talking when you started talking on top of him? Just to these are genuine questions that I have. Please be aware when you interrupt people. Sorry, Adam, what was that? No, we hired that person. These are now the new, good question. but these are the new 7th graders for next year. Yes. We didn't do this with you, but then we decided we probably should, especially since we're still in the middle of a pandemic. And recruitment was weird this year. Like, we got to recruit you guys last year, right? Like, we came to your schools, and then everything shut down. So this year, because that didn't happen, we decided we need to meet with the new people, make sure they actually understand what they signed up for. You know, little things like we don't give letter grades, and our day ends at 4:30. Just those small things that sometimes we get to, not April, sometimes we get to August, and people are like, wait, 4:30? And we're like, you don't okay, let's back up. Welcome to Phoenix. We're alternative. And that's bad, right? When you get to August and that's happening. So we're going to do that now and try to catch those people and be like, this is what you signed up for. Make sure you want it. There are no coordinates to actually reference here. So all we can really do is look at kind of like our X, Y directional. So from B down to P. Anyone get that all measured out? 12 down. And then how far over? 8. So then a scale factor of 1/3. Ooh, good thing those numbers work nice. Oh yeah, crap. B's are, well, good thing they work nice still. The 8 was not going to work nice with the 3, but good thing it's a 4. So I actually turned that into a 3, and I actually turned that into a 2. Okay, so 1, 2, 3. Oh, this got a lot easier. Any question? So wait. We're plotting the image of B. Oh, wait. Image of B. Oh, image of B. Okay. Why didn't you speak up? Are you sure? Oh, I just labeled that one wrong. Sorry, I didn't actually do that one wrong. Yeah, I wrote B. Sorry, guys, this on the back was intentional. This on the front wasn't, actually. That should have been labeled A prime. Sorry, but back here, yeah, double check what you're doing and what it needs to be labeled. So this distance divided by 3, but then what we're actually doing is instead of stretching B as far away as it is, we're only stretching it. Remember, we start at P. We only go 3, 2. So 1, 2, 3, 1, 2. And that's actually B prime. Over here, same deal, except it's a scale factor of 1/3. So since this is, this one's 3, this one's 6. We get 1 and 2. And, oh, that's from the origin, so that feels a little easier. Oh, I gotta go check if there's more donuts in the office. What? They said come to the office, and I was like, oh yeah, donuts. No, what would be inappropriate is if I left class to go check for donuts. Excuse me, office, are there approximately 24 donuts left? My 3B class would like to know. Man, I can't record myself taking a bribe. Let me pause this real quick. See, at least Nick understood the joke I made. Yeah, in like 3 minutes, but that's enough for 3 minutes of learning. To determine the scale factor, our scale factor can always be found through division, and it's always going to be the image divided by the pre. So we take anything from the image, like a length, and we compare it. Nobody? Nobody? Is this the image? No, this is the pre-image. I called it the image. You all should correct me. All right. Pre-image, image. So make sure we put the image on top. Scale factor of 2.
No, 1/2. Oh, wait, yeah.
Remember, we're going from. We're going from. And our final one here.
Scale factor of a third. It was, at first I thought it was going to be 3, and then I'm like, oh wait, it's the other way.
This might date myself a lot. Well, probably. Anyone think this looks like an asteroid? Like from asteroids? Like I need to shoot at it with my... Like this needs to be spinning and coming at my spaceship? No? Okay. I'll come around with wipes while y'all...
No, I would down. I mean, I would collect.
I have the Segway version of Segway. You mean Sega? I have the Sega from like Target that comes with like 150 games or whatever. I'll have that on sale. Nice.
I own the car, but I can't find anything that it'll plug into.
Oh, you have to plug it into a VCR.
Oh my gosh, a VCR. What is that?
Actually, the thing is, people think, the thing is, Mr. I know exactly what that is, and I used to use it to watch Arthur.
All my kids' movies at home are still on VHS tapes. Like my parents have the originals.
Nobody knows what a VCR is, and I like grew up with a VCR.
How do I get to my recorder?